Welcome to our second sample solution from exercise group 9.2. I want to focus on 9.2.1 I this time. Our first set member is for any z, hz, and our second set member is there is an x, hx, horseshoe, for any y, fy. So on line 2, we have a truth functional compound. On line 1, we have a universally quantified sentence. Remember, it's a very good idea to remember how to identify the main logical operator of a sentence in predicate logic. The main logical operator of the sentence on line 2 is this horseshoe here, and that's why I called it a truth functional compound. Whereas the main logical operator of the sentence on line 1 is this universal z quantifier. Okay, in this particular problem, it's probably a good idea to first decompose the sentence on line 2. First, we're going to get the negation of the antecedent on one side, and then for any y, fy on the other, and that's just going to come from 2 by conditional decomposition. Now I have these two branches that I can work on pretty much independently. On the left side here, I have a negated existential quantifier, so I can write down for all x, it's not the case that hx. And that's kind of interesting. Okay, so that came from 3 by negated existential decomposition. It's kind of interesting because line 1 says that for any z, hz, whereas line 4 says that for any x, it's not the case that hx. So I can instantiate both 1 and 4 to the same constant and get a contradiction. From number 1, I can write down HA, where I substitute in A for Z. I know I said before, it was a slip of a Canadianism in there for y'all. So that HA comes from 1 by universal decomposition. And now I can write down it's not the case that HA from 4 by universal decomposition. That's a contradiction, so that branch closes. Now I can go and work on the other side. I draw this line here just so I can always make sure that I have a justification for each and every line in my tree and only one justification for each and every line in my tree. So on this left side here, I've got 2 universally quantified sentences. And although I can anticipate that the tree is not going to close because one uses the predicate F and the other one uses the predicate H, I have to instantiate them once each before I can conclude that I have a completed open branch. So I have to write down HA, and I can use A even though I've used it before. That doesn't matter when it's a universally quantified sentence. HA from 1 by universal decomposition, and then I can write down FA from 3 by universal decomposition, and now I can conclude that I have a completed open branch, which I can indicate with a small circle underneath that branch. So in this case, there does exist an interpretation on which both of my set members are true.